Amazing morning, grade 9 students. Welcome to another episode of Valenzuela Live Science 9. Today, we will continue our lesson about projectile motion. So prepare now your science module, notebook, and ball pen. It would also be better if you have a calculator with you. Here are our objectives based on the most essential learning competencies crafted by the Department of Education. First, investigate the relationship between the angle of release and the height and range of the projectile. Second, demonstrate what happens to the height and range of projectile at different angles of release. Third, infer from examples that the angle of release affects the height and range of a projectile. And last, use examples derived from sports to show that the angle of release affects the range and height of a projectile. Before we begin our lesson, let us play this game called Guess the Gibberish. In each round, you will be given a set of words and you should identify the hidden word based on how you pronounce them together. Number 1. Type your answers now. Time's up. The correct answer is initial velocity. Were you able to get the correct answer? Then that's good. Number 2. Type your answers now. Time's up. The correct answer is horizontal velocity. Wonderful! You got the correct answer again. Number 3. Type your answers now. The correct answer is vertical velocity. Wow, you are really getting good at this. Number 4. Type your answers now. Time's up. If your answer is launch angle, then you are definitely correct. Number 5. Type your answers now. Time's up. Amazing! Range is the correct answer. Number 6. Last number. Type your answers now. Time's up. The correct answer is height. Job well done, grade 9 students. Initial velocity, horizontal velocity, vertical velocity, launch angle, range, and height are some of the terms we have learned when we discuss about the parts and characteristics of projectile motion. For today's lesson, we're going to investigate the effects of launch angle to the range and height of projectile motion. Let's start with these examples. In these clips, from a game I played, I launched 2 birds with the same amount of force. Thus, they will have the same initial velocity. As you can see, the 2 birds traveled different lengths of distance despite having the same initial velocity. In which trial did the bird travel in a longer distance? Type your answers now. Thumbs up. Obviously, the bird in trial B traveled in a longer distance than the bird in trial A. Let's make another comparison of these two examples. In which trial did the bird reach higher height? Type your answers now. Thumbs up. You got it right. The bird in trial A was able to reach a higher height than the bird in trial B. What do you think is the cause of these differences in range and height of projectile motion of the birds in these two examples? Type your answers now. Time's up. That's right. All other factors are the same for both trials except the angle at which the birds were released. Let's have here more examples of projectile motion, released at different launch angles. All these 7 new trials were simulated with the same initial velocity of 20 meters per second. This is the first one. Trial A shows a ball launched at 0 degrees from the x-axis. Number 2. Trial B shows a ball launched at 15 degrees from the x-axis. Trial C shows a ball launched at 30 degrees from the x-axis. Trial D shows a ball launched at 45 degrees from the x-axis. Trial E shows a ball launched at 60 degrees from the x-axis. Trial F shows a ball launched at 75 degrees from the x-axis. Lastly, Trial G shows a ball launched at 90 degrees from the x-axis. Which trial leads to the longest range? Type your answers now. You're correct. Trial D, with a launch angle of 45 degrees, led to the longest range. Which trial lead to shortest range? Type your answers now. Time's up. You're correct again. Trials A and G with the launch angles of 0 degrees and 90 degrees respectively led to the shortest range. With these examples, we have learned that projectiles can reach the longest range when the angle of release is 45 degrees and can reach the shortest range when the angle of release is either 0 degrees or 90 degrees. Therefore, the closer the angle of release to 45 degrees, the longer the range the projectile will travel. In your previous lessons in math, you have learned about complementary angles. Can you still remember what does it mean? Type your answers now. Very good, students. Complementary angles are two angles that have a sum of 90 degrees. As you can see here in the table, we have 3 pairs of complementary angles, 090, 1575, and 3060. Now, what can you say about the range of projectile released at the complementary angles? Type your answers now. So, that's right. ranges of projectiles released at complementary angles are equal. A while ago, we also found out that launch angle can also affect the height of projectile motion. Now let's examine it. Here are the results of trials A to G. Which of the following trials reached the highest height? Type your answers now. Time's up. If your answer is trial G at 90 degrees, then you are definitely correct. How about the trial that resulted to the lowest height? Type your answers now. Time's up. Yes, it is definitely trial A at 0 degrees that resulted to the lowest height. Using this table, how does launch angle affect the height of projectile motion? Type your answers now. Time's up. Very good. From 0 degrees to 90 degrees, height increases. And this idea is also supported with the time the projectile stays up in the air. The longer their time, the higher they can reach. You may also consider downloading educational application from Play Store to help you in understanding the lesson. In our previous lesson, we learned various quantities related to projectile motion that can be calculated by separating first the horizontal and vertical components of it. And with the use of this formula, we can calculate the range and height of projectile motion. There are actually other easier ways to do it, just like using this formula that were derived from the formula we used last meeting. Wherein R refers to the range of the projectile, H refers to the height of the projectile, V stands for the initial velocity, theta refers to the angle of release, and G for the value of gravity or acceleration due to gravity. For gravity, we're going to use positive 9.81 meter per second squared. The positive sign came from the way this formula were derived, which we won't discuss in this lesson, but you will surely learn in the next years of studying science. These two formula are easier to use because there is no need to identify variables like horizontal initial velocity, vertical initial velocity, and time. Let's have this problem. In a golf match, a man hit a ball resulting it to move at 60 meters per second in 30-degree angle. Assuming that air resistance is negligible, how far will the ball travel before it lands? We're going to do 5 easy steps in order to solve this problem. First, list down all the given. Second, identify what is required to find. In this problem, we have to calculate the range. Number 3, identify the formula to be used. Number 4, substitute the given values to the formula. Step 5, carry out the computation. So, how far will the ball travel before it lands? Write down your answers. Time's up. Very good. the ball will travel approximately 317.81 meters before it lands. This problem is quite similar to problem number 1, so we will still follow the 5 easy steps. First, list down all the given. Second, identify what is required to find. For this problem, we have to calculate how high the ball will reach up in the air. Step 3, identify the formula to be used. Sine squared theta can also be written as squared of quantity sine theta. So we can also write our formula this way. Step 4. Substitute the given values to the formula. Step 5. Carry out the computation. So, how high will the ball reach up in the air? Type now your answers. Thumbs up. That is correct. The ball will reach approximately 45.87 meters up in the air. Concepts of projectile motion are usually observed from various sports such as volleyball, golf, shot put, archery, badminton, javelin throw, and many more. Can you think of other sports that involve projectile motion? Type it in the comment section below. Basketball. Definitely, basketball involves concepts of projectile motion. It is really hard to make successful three-point shots since players have to shoot the ball at longer distance than their usual shots. At what angle should players release the ball to make it travel in a longer distance? Well, based on our lesson, it must be equal to 45 degrees to achieve maximum range. But most players shoot balls at slightly higher angle of 48 degrees for them to still be able to see the basket when they are shooting the ball. Today, we learned that launch angle can affect both range and height of projectile motion. At 0 degrees, both range and height are at the lowest possible value. At 45 degrees, the range is at maximum value, while the height is just average. At 90 degrees, the range is at the lowest value, but the height is at maximum value. For angles between 0 and 45, the range is shorter than the range in 45 degrees, and the height is also lower than the height in 45 degrees. While for angles between 45 degrees and 90 degrees, the range is still shorter than the range in 45 degrees, but the height is higher than the height in 45 degrees. And with same initial velocity, projectiles released at complementary angles have the same range but different height. Just like here. Now, let us check your understanding of the lesson. 5 questions will be shown. You have to press the corresponding reaction button for your answer. Are you ready now? Then, let us begin. Question number 1. Choose your answers now. Time's up. The correct answer is 45 degrees. Very good, everyone. Question number 2. Choose your answers now. Time's up. That's right, the projectile can reach its maximum height when released at 90 degrees. Question number 3. Choose your answers now. Impressive! Your answer is correct. Both will cover equal range because 25 degrees and 65 degrees are complementary angles. Question number 4. Choose your answers now. Time's up. If your answer is ball Y, then you got it right. Ball Y will reach higher height than ball X because its launch angle is closer to 90 degrees. Question number 5. Choose your answers now. Time's up. Excellent! The golfer must hit the ball at 45 degrees to cover maximum range on his first strike. Job well done, grade 9 students. That's all for today. For deeper understanding of the lesson, you will have a follow-up discussion with your subject teacher. So once again, I am Sir Isaac. Thank you everyone. See you in the next episode of Valenzuela Live.